In this video, we're going to be looking at moving between log and index form. Now, you don't really need to understand a lot about what logs are or where they came from, but in summary, they are basically developed to help with solving bigger multiplication and division problems. And that was done by turning them into addition or subtraction problems with the use of these log tables that were created, big lists of numbers that were used to help change the way they thought about these numbers and made them easier to do bigger problems. And so they're connected with powers. And so today we use logs more for exponential situations. And so in this video, we're looking at moving between index form and log form. And so this is log form here. And we do have how to convert here, but we're just going to think about this question first. We've got 2 equals log, and the 4 there, the little 4, we call that a base of 4, and then we've got 16. Now, if we look at these numbers, you might notice a connection. Hopefully, if you look at the connection between them, you might see, well, 4 to the power of 2 is equal to 16. And so if we were to write that down, 4 to the power of 2 equals 16, we would have converted to index form, to this form, y equals b to the power of x form from this one here. And so that's all there is to it in terms of going from index form to log form. And so if we look at this next one, 3 to the power of 4, so that little number is our base. 3 to the power of 4 equals 81. The next one, the little number after the log, that's our base, which we then the power is over the other side of the equal sign, so half, and 49 to the power of a half. Now remember, anything to the power of a half is the same as square rooting, so the square root of 49 is 7. Now, if we're going back the other way, we've just got to think backwards, and we can use these to help us if we're kind of stuck. We can see that, well, the y here, the number that it's equal to, so 100 corresponds to what's inside the log. The x, the power, is what's kind of out in front, so we've got this 2 there, so that's going to be equal, and the number that's been acted, the base here, that's going to be there, and we've got that. So 10 squared equals 100. And if we continue doing that for these other ones, our power is 5, so it's 5 equals log, and our base there is 2 equal of 32. So 5 equals log with a base of 2 of 32. And here, our power this time is -2, and log, our base is 3, and that is 1/9. So 3 to the power of -2 equals 1/9. And so we can use this concept to find missing numbers sometimes. So if we were to go to index form here, so our base is 6, 6 squared to the power of 2 equals x, and so that means, well, 6 squared, that means that x is going to be 36. Or there's our base, so x to the power of 5 equals 32. So x, the number that times is by itself 5 times to give 32 would be 2. So a little bit of trial and error here. And this one here, 27 to the power of x equals 3. So remembering that, well, to get from 27 to 3, we're actually going to have to cube root 27 there. And that will give me 3. And so cube rooting is raising to the power of a third. So x is going to be a third there.